today I'm going to show you how to calculate derivatives such as f of x to the power of g of x. Here are some examples of how these functions might look like. We are mainly going to use the formula a to the power of b equals e to the power of b natural logarithm of a. We will also need to know basic derivatives formulas as well as the chain rule. So here's our first example, y equals x to the power of x. To calculate this, we treat the first x as a and the other one as b, and we apply this to the formula. What we get is e to the power of x ln x, and we have to calculate the derivative for this function. Using the chain rule, we get e to the power of x ln x and the derivative of x ln x. So here we apply the product rule, and after the simplification we get e to the power of x ln x times ln x plus 1. So let's move to the next example. Here we have x to the power of sine x. So we do it the same way as last time. We treat function x as a and function sine x as b. We get e to the power of sine x ln x, and we calculate the derivative using the chain rule. Here again we apply product rule to sine x ln x. The derivative from sine x is cosine x, and the derivative from ln x is 1 over x. All in all, the answer looks like that. The next example looks like that. We've got cosine x to the power of sine x. And again, in this example, a is cosine x and b is sine x. In the next step, we apply the chain rule. Then we rewrite our e function and calculate the derivative from sine x ln cosine x. Here we have to distinguish two functions, where the first one is sine x and the other one is ln cosine x. And then we can apply the product rule. To sum up, the answer looks like that. Here we've got our last example. X to the power of 2 plus 1 in brackets to the power of x. In this case, a would be the whole bracket, so x to the power of 2 plus 1, and b would be x. Then we follow the same steps as during the previous examples, so we apply the chain rule and the product rule. What is worth mentioning is that we apply the chain rule for the second time for the function ln x squared plus 1. And the final answer looks like this.